Good afternoon, everyone. My name is Evan Luco, and I am the lead on this year's automated storage and retrieval system. Today, you'll be hearing an update on our progress to date on this system, as pictured here. We'd like to thank our customer, Chris Dick, our technical advisor, Daniel Barrett, our communication advisor, Joan Magnuson, the Omron representatives, Stuart and Chase, that aided us with the SRS, as well as everyone in attendance today.
Hello, everyone. My name is Nadina Buforn, and I will be discussing our progress with the counterweight system, as well as the tray designs.
Hello, my name is Hans Magtanong, and I'm here to explain the state of the control cabinet and the control box.
So today we will be covering our project purpose, the project problem statement, just brief overviews, the control cabinet, our human-machine interface, our use of PLC and the Sysmac program, our control box schematics, our counterweight system, the tray redesign that we effected, our end effector, and then we'll conclude out the presentation and have a Q&A session. So the SRS system exists so that a lot of items could be stored and accessed easily by the ABB robots in lab. Due to the robots having to access it, it has to be within the control or the robot cabinet or robot area in the lab. So that's obviously something where humans couldn't easily, it's too dangerous for them to actually give the robots any equipment. And it's a very easy process, or it's a process that could be automated and done much more effectively. As we introduced in our previous presentation, our project was outlined by these 5 major objectives. And as we draw to a close, we've made significant progress, but we weren't unfortunately able to meet all of our objectives with the SRS. To date, we've been able to repair the cables, have implemented the HMI system, as well as complete extensive documentation. However, we weren't able yet to establish communication with the robots in lab.
Starting the project, there are some cables in the control cabinet. With the help of the multimeter, we determine each of the end of the wires and identify the unlabeled connections. Those cables are identified as the 702 to 705 cables. These cables are important because they communicate between the control box and control cabinet, which sends signals to the control cabinet, where the PLC is located. We decided to power up the ASRS so that we can extract the program from the PLC. We also discovered that the relay does not have any connections to the 303 distributor that helps them give power. When we look at the distributor, there's no open slot that enables us to connect them to the power supply. So we used the jumper wire to power up the relays. Once it had been known where all the cables are supposed to be connected, and after we extracted the program from the PLC, we decided to reroute one cable at a time through the cable channels until all of them had a clear path. One challenge that we came across was the length of the wires, as we didn't want to pull on them, as this might cause wear or internal tears. For the control box, we noticed that one of the terminal blocks did not receive any power from the control cabinet. We decided to use a jumper wire and connect that to the other terminal block that has some open slots. After the terminal block was powered with the help of the jumper wire, we then used the open slots to connect the proximity sensor. Looking at the schematics, the picture to the left is the proposed schematics and the right is the old schematics. After thinking it thoroughly, we decided to abandon the idea of proposing a new schematics because we didn't think that if we change the connections of the turbine, we would also have to create a new program, which is also just a waste of time. After putting it back to the way it was, we noticed that the cable display was missing, which shows here in the schematics. After we found out where the cable display is, it is revealed that the label of the cable display is the 707 cable, which the schematics did not mention.
As Hans mentioned, that 707 cable was linked to a system-specific human-machine interface screen. Initially, we had the preconception of using all 8 HMIs in lab to request parts from the SRS for their specific robot. So that's part of the reason why we weren't initially aware of it. It also wasn't labeled at the time, so we affixed these labels in lab, so it was more evident what this HMI's purpose was for. This is the PLC that's found in the control cabinet. We had Amaron representatives come in and show us how to extract the program and utilize Sysmac to move the motors and edit the program. As presented in our last presentation, this was the morphological chart that we constructed displaying potential concepts. Our tray systems, we decided to use compatible tray, which was compatible tray, which was found in option 1, and our counterweight system, which we followed the concept that we brought up in option 3.
So our group decided that we would use a multiple pulley system, as you can see here in the picture on the left. Unfortunately, we weren't able to implement that yet. We had access to the counterweight pole, and it is to implement. In order to implement this design, our idea was to create removable weight plates in increments of 5 pounds, like the green plate here shown on the right, to achieve our 20-pound desired weight in order for us to balance our end effector. Once in place, these would be put the least mounting to strain on the motors, as they would have provided an acceleration in any direction. And the ASRS initially used an aluminum tray, which is in a square. And as you can see in the picture here, it's bigger than the conveyor belt size. So what we decided to do is to create a new one. And this was originally problematic because we couldn't cut the aluminum tray. It was very expensive material. And originally, what happens is when both trays move on from opposite sides, as the conveyor belt move in opposite directions, this can cause a collision, which is not safe. So my team and I decided to use an alternative material since we were advised we shouldn't cut down the aluminum. As you can see here, we redesigned a wooden tray that would have the same width in the conveyor belt from the bottom, but a slightly bigger one on the top to be able to carry it from the ASRS shelves. These trays are also have drilled holes to be able to be mounted on the ASRS shelves safely. So to accommodate with the changes of the trays, we also changed the end effector, the part with a small groove in the picture on the left here, and to get a better grip on the tray when lifting it from the ASRS shelves, which they are originally thinner. So the picture on the left here shown, Hans has gone and designed a wider end effector, which is done through SolidWorks, and this is supposed to replace the thinner trays in the left here to be able to have a better grip and to lift the trays safely.
Right. So to ensure we were staying on track monetarily, we constructed a bill of materials, which includes all the components of the SRS. After we constructed this list, we went and created our project's cost analysis, which includes things like cost of labor and other external costs associated with the project. We also created a value of engineering chart, which shows where the project budget was allocated and where that can be found within the SRS, which brings us to the current day. So in conclusion, we were able to complete many of the project objectives, and we're very proud of the work that we were able to accomplish. We were able to examine the program and power up the SRS, improve on the existing systems, and provide documentation for each of those systems. The SRS 2021 ASRS project was a great learning experience, and we look forward to passing on all the information and lessons that we've learned during this project to teams for the future that will work on this. We'd like to thank everyone for your time and attention today. And if there are any questions, we'd be pleased to answer them now.
I have questions again. You guys were talking about how you were redoing the end effector and the plates on the conveyors. Coming from a food manufacturing facility, why did you end up going with wood and not going with like a 3D printed case that would be more cost effective and more ready available in that lab?
At the time, it was more so a time constraint thing. The wood, since we just needed the actual changes to the block of wood were very minimal. So it was just something we could easily get for hands-on for prototyping at this point. We weren't redesigning all 40 of the trays on the SRS. It was just more so of a prototype to move forward and at least double check and make sure that it was an actual concept that we could move forward with that was effective. Yeah.
Okay.
Also, sorry, to add on what Evan had said, the reason we also chose wood is because maybe 3D is not available to everyone, or sometimes your 3D printer wouldn't print the way it should be, or there's like some malfunction with it. So wood is really accessible. It's really easy. It's fast to do. Just cut down the pieces required.
That is fair. I just missed the point where that was a prototype. The way I heard it, it was a newly implemented, this is what we were doing.
For sure. Fair enough.
Yeah. As for
Thank you.
comments, I was really happy with the presentation you guys came with this time. I was very intrigued to see what you guys were going to do with this. And yeah, I think you guys did a very good job. And I'm glad to see a good amount of progress done this year. Thank you.
Certainly, Lane. Thank you very much. All right. Were there any other questions?
Hi, Evan. You said near the start problems trying to get this to communicate with the robot. Can you expand on what the difficulties were there for your team?
Well, unfortunately, it was just due to things that we had to go back, look at, and kind of reevaluate. We didn't really have time over the project, just due to our lack of familiarity with Sysmac and in the earlier stages of the project to actually look into that sort of stuff. So that's something that we hadn't really had an opportunity to really look into all that much. So we do have information on that now that will be including in information that we'll be passing on to the next team. So we've got the PLC program as well as documentation in regards for Robot Studio and Sysmac that we'll be passing on so that they can implement that moving forward.
So sorry, I just want to expand. So it was communication protocol, or was it Sysmac, or was it Robot Studio that was really giving you the difficulty there?
Well, like I said, we just at the time, like we hadn't had a lot of time. We weren't able to get. We weren't really aware at the time we weren't in Sysmac. We didn't have the program at the time to actually work with it. So it was just kind of a lack of having the PLC program there to look through it, understand it, and then understand how we could actually go and have communication set up in there. So
thank you.
Yeah. Oh, was there any other questions for anyone I could address? We could address it all, or? It's not. All right, then we'd like to thank everyone again for their viewing of our presentation. We really appreciate it. And again, we wanted to thank everyone for viewing it and everyone who's had a hand in aiding us, our advisors, Omron representatives, and the like for all that. And again, thank you very much.
Excellent. Thank you, team.